Hello, this is another practice video for Advent of Code 2022. So in preparation for the 2023 Advent of Code thing. Okay, I've just done 2 videos and I love these puzzles. I'm gonna do another one right now. Time more difficult one this time. I think I remember that I enjoyed it, but I do remember it's the parsing and stuff is time more difficult. So I hope you enjoy this. This time I will go time more quick. We'll try to see how I would solve it myself and then explain a little bit throughout. And then I will gonna treat this as if, I'm seeing this puzzle for the first time. And I'm going to actually try to solve it as fast as I can. And then I will explain my solution and my thought process as I go. So I would say let's get cracking. Obviously I would have all of this prepared. I already have 5 downloaded though, because of my first video that I made. So let me just take this and I'm going to say, I'm going to keep this open. So let's get started. So giant cargo crane, moving stacks between them. So these are the different stacks. I remember that from last year. And then we have starting stacks and a rearrangement procedure, which is our puzzle import. So this has actually 2 types of data. Let's see, move the procedure. We say move number from number to number. In this case, so it moves 1 from 2 to 1. So D moves on top of P. Is that correct? On top of N because it goes to the left. Okay. Now, it does this 1 at a time. Okay, so this is important because if we say move 2 or move 3, it does them 1 at a time. Okay, so it changes the order. And I think if I remember from last year, the second part of the puzzle is where it does a whole thing instead of 1 at a time. So I may already want to go ahead, and then I want to know the top ones of each. So this sounds like a puzzle where the right data structure would be important, because I can just pop the top one. A stack. I essentially want a stack, which that is literally is a stack. The elves just need to know which crates will end up on top of each stack, and then I get the solution word CMC. Okay, so the solution word is CMC. And this is my puzzle example. It seems like, and I'm talking a tiny bit as I'm trying to get my process, it seems like it's very carefully spaced. So it seems like for each stack we have 3. Between each stack is a space of 1. This is important because if we read it row by row, this is what we see first. And this is really difficult if we don't know the spacing to know which of those stacks go on top of which. Furthermore, if it's a stack first in, first out, I kind of want to read it from down here, unless Python gives me the option to do both. I think Python gives me the option to do both with the list. This row is completely useless. This row is almost completely useless. This row will actually be really helpful for me to get to this part. So the parsing is the most important thing here. I have an idea how I would do it in Rust. Funny enough. Because I can, through parsing and stuff like this, I can create objects and stuff like this, but here it wouldn't work. I don't think. So here, I'm not quite 100% sure right now how I would read out the stuff, because I don't remember with Python. So I'm going to say, substring? Is there some type of substring? in Python. Is there some type of substring? Oh, I just say string and then start and step. Okay. Okay. Oh, what is this? No. Start and end. Okay. So first of all, each row. It is again important for me to know that each row does certain things. I'm going to kick all of this out. I'm just going to say here 2 empty strings, and I'm going to do all of this later. I want to work line by line, which is usually the case at these things. So line. If I now print line individually, I will get those individual lines. Now, I want to say substring. What is, no, string. Oh, string. Oh, okay, I getcha. And I just want to say the first 3 of each line, which will give me nothing, and then a box and a box. Really? I don't even care about the square brackets. I only care about this portion. So there's nothing N and Z. Okay, I have an idea. For I in range. No, not in range. While I. And I don't want pure I. So I equals 0. And while I is smaller than the length of the line, I want to keep processing it. Now, not just I, but I plus 2 or something like this. So it starts at 0. And say I plus equals 3? No, 4. Yeah, we start at 0. That is 0 is this first character here. And 2, 3, 4. Wait. 1, 2, 3. Yeah, it's plus 4. Plus equals 4 because we have that space. Now I'm gonna get an overflow error. I'm not. So nothing D, nothing NZ, nothing ZMP. That is correct. That is correct. I'm actually gonna say plus equals 1, and I'm gonna say times 4, because I also want to use I to address the corresponding stacks. So I'm gonna create stacks, and that's just a list. Initiate it as a list. And then I'll need to rearrange the list. I need to flip the list around afterwards. Unless I can say if I need to first initiate it. If I equals let's do it. I need to do that on top. If I equals 0, I need to first create the stack. Stacks of I equals a list. Yep. And then I'm gonna say stacks I dot append. It adds it to the end. Yes, that's what I want. No, I don't want it. I want to insert that. So this is my value. Val, boom. Now, if val equals this, then continue, because I don't care about, so that's my guard. And then I'm gonna say I want to insert the value in the beginning. Enter the object? Wait, what? self-index object. Okay, so into 0, this way around. Okay, and then I'm going to say I plus equals 1. At the end of this, I should get all of the stacks correctly. However, we're going to have an issue once we hit the numbers. Let's check the puzzle input because, yes, these are all just letters. So I don't actually want it to be a number. So if the value is a space, or if val equals or is number. What does Python do again? So here you see that I just Google things. I know what I wanted to do. I just don't know the specific syntax because I've worked more in JavaScript recently. Also, I've tried to dabble in Rust, and now everything is lost in Python. But Python, I want to know about is number. Python string is numeric. I figured it was something like this. Okay, is numeric. Why did my Intel parsing? Okay, that seems like it's working. Now, there's another thing that we need to consider is the numbers we can ignore, and the numbers actually fall on exactly the same line as the letter, so that is helpful. But I have this empty string, and that one actually seems to be truly empty. So I will, yeah, it's truly empty. So if I know I reached a line that has a length of 0, I'm actually at my next step. So I'm gonna just say step equals 0. That would be more like a state. I mean, I could call it state. State is stacks, right? While for each line, so if state equals stacks, it should do all of this, right? And I could put it out into a different function, and I might do that at the end to clean up, but not right now. Now I'm gonna say else. If it's not stacks, then I want to do something else, and I'm just gonna pass for now. Okay, that's where we get to afterwards. Now, if this is not going to do anything, which is nice, if it's the empty line. So if I say line, if length of line equals 0, then I know state is now the procedure. And really, it doesn't matter what I write in here. It's not stacks anymore. That's what's important. And now I'm not going to put anything awful in it. And now I should be able to print out what my stacks look like. Now, I don't think Python is going to show me in a nice way because, oh, I'm getting an index out of range error. Ah, of course, that is the whole point of me doing this line in the first place. Stacks dot append just an empty. That is not a good sign. That is really not a good sign. Ooh, what? This is taking forever, which means I have some type of infinite loop going on here. And if I had to guess where that would be, it's probably in my if statement here. It's what I said at the beginning. I don't just care if I if I is smaller than length, but I times 4, if that is inside the length, that's still not it. That is still not it. Okay. Yeah, that's right. Why am I appending this again and again and again? That's not correct. I'm not every row I'm appending. No, that. Um. Still having an issue there. This whole appending this is not working correctly. Is it doing what I'm expecting it to do? And this now is going to take forever because I'm actually having to debug each individual line. This is really annoying. Let's see. So we have currently this. We have first line is true. Now, while I times 4 equals smaller than the length stuff, the line. How long is this line? How long is, can we, it doesn't tell me what this is in this case. Just that this is true. And then I'm getting the value, which should be nothing. And it is still the first line, so it should add to it. Yes. Now if value, so we're gonna continue. Oh, of course. That's where my endless loop comes out of. List out of range. Okay, that's now more doable. 0.val in stack I. Okay. Because I'm adding it too soon here now. Okay, I think I've got it now. Yes, okay. So, haha! Zn. So, Z is first because it's the very bottom. Zn, correct. Then we have MCD, that is also correct. And then we have P. Good. Good. So we have the stacks correctly, which is amazing. And now we are at the procedure phase and actually need to manipulate the stacks. So each line, now that we're in the procedure phase, each line does something to those stacks. And that's actually fairly simple. Yes, let's go for it. My thought process was right now, if I remember right, in the second half it does the whole stacks. Can I already optimize for that? I'm just gonna code. I think if there would be just one thing that it could do easy, it might be. I think I might be. Really, if you want to do this as fast as humanly possible, you would just change the code and not care about it. That's what you really want to do. If you want to be as fast as possible, program it, look at the second prompt, and delete things and change things to make it work. That's what you want to do. That's not what I want to do. I don't care enough about speed for me to do this. Oh, sorry, that's bad. Here, that's procedure. Procedure. Okay. Is this not correct? Ah. Interesting. Let's keep going. If this is annoying yet, then I'm not gonna do anything. Okay, let's go for it. So the interesting thing is that this is always, like, we always have move, we always have from, we always have to. So I can actually split by this, can split by this, can split by this to get those values. Is there a better way to do this? So I don't know. I don't think so. Amount equals, or amount and leftovers equals to line.split. Line.split, and the important thing here is to split by this portion. Okay. Then I'm gonna say I need to split by this portion to say from and to. From to F and T. I see, you can be so knocked down by naming things, and really you don't care too much about naming things. From and to, boom. So I should be able to now print. Amount is still not 100% correct, but F and T should be. Yes, so it says move 1, and then it gives me the numbers. Okay, so I need to now, I know it is 5 letters, so I actually just want 5. Boom. But I also want to make sure that these are numbers. And everything should be -1, except the amount. Okay, so here I'm gonna say map lambda x, and I want to say int x and then -1, because the indexes should be starting at 0, but they're starting at 1, which we can see right here. Okay, so that is from F and T. I need to make that a list, a tuple, whatever. Can make that a tuple. And then the amount equals to this, but still I need this to be an integer. Okay, so we don't see the difference, but we have now all of the values that we need. Perfect. If we are in the first half, we... Oh, this is... No, we need to redo the whole thing twice. In this case, I need to have the solution twice. I'll get to it. Okay, I think, yeah, okay. I think what I'm going to do. So we have amount, F and T. And the first stack, it does it 1 by 1. So I essentially just say for I. Did I use I already? Up there. So, okay, for I in range. For I in range. So, the amount. And that is non-inclusive, if I remember right. So this should work perfectly. And so we do that each time. Honestly, I actually don't care what this is called. I really don't. And now I'm just going to say stacks from, and this is correct, move from to the 2. dot pop, and pop should do at the end. Default is last, so okay, perfect. So val is this. So we are taking out from the stacks, and then from stacks f, and we're putting it into stacks t and append it. And now we should have CMZ. Perfect. Now you could obviously, since you see the solution, you could now do it yourself, but I want it to be still clean code. So I'm actually gonna go now and say, I'm gonna go through each top and pop and add it to the answer, okay? S1 equals this, and 4 in stacks. S1 dot append. I think that's how I do that with string, equals s dot pop. And then should be s1. How do I append a string in Python again? And string. Oh, plus. Of course. So simple. Aha! And this is now my solution. Oh, hit the window. Come on. Gold star, it was correct. Now, creator mover. Okay, they will pick up multiple crates at once. Stay in the same order. Okay, so this time it does not change the order. And MCD is the second answer. So once I enter that here, it's going to be like, it's wrong now, which is totally to be expected. Okay, so this is really interesting. What I'm going to do, all of this, I'm going to put into a subsolver. Okay. And then I say define sort stacks. Okay. And then return S1. And really I can, S1. And then sort stacks. I'm going to give it the value D, and I want to also give it a Boolean, say, individual equals true. Okay, so now all I need to do here is I say sort stacks D, and then sort stacks D false. Okay, and then what I'm going to change here in sort stacks, okay, you're probably unhappy, which is fine, is the way that I do this. I have two options. I could... Okay, I don't know if I... Is there such a thing as take certain amounts? I think there is. Python take from list multiple items. Because I know in... Yes. And then append multiple items. Python append multiple items to list. Dot extend. Perfect. That's exactly what I need. Okay, so this little thing is only if individual. If individual, then we do it this way. If it's not individual, and this is where you would usually just change it, but here it's just a simple, like where you would just replace it. Here's a simple change. Here I'm gonna say stacks the stacks f. Oh, how do I remove multiple items? Oh, I know how to get multiple items. Okay, so stack of t equals dot extend stack f, and then I want to say the start is minus amount. That should be it. That should be it for adding. And then I say stacks delete stacks f minus amount. Let's see if that works. Ah, that worked. Okay, that was a gamble because I didn't I've not 100%ly done this before, and it works. Okay, let me explain what I did. Okay. I'm glad that this worked. Okay, so I have now a function called sort stacks that does the same thing twice. Really, if I was to refactor this, and I didn't want to do this because of speed now, but if I was to refactor this now, this first part I only need to do once, and I already have the stacks. You know what? I can do that. I can refactor right now. Okay, so get stacks. Okay. And essentially just give it a copy of it, give each of them a copy. I'm not going to do it now, but you could do just this very first thing. You only need to do once because that's your starting array in both cases. Just what the second half of the procedure does changes between the two tasks. In the first task, it takes each thing individually. In the second task, it takes the whole thing as a whole. So again, this whole first part here is exactly identical for each of those two tasks. All of this is exactly identical. Now we get to the second half, and that changes. And we're changing it depending on if we have set individual to true or not. So I have sort stacks, and it is individual, and then sort stacks where individual is false. And we're checking that down here and doing something slightly different for each of those cases and returning still the very top of the stack in each of those cases. So that's why these two functions give something slightly different, and we're returning that in our solve. Okay, what exactly is happening? We are processing our lines, and then we initialize our stack lists, and we say, hey, our first state is stacking. We need to find the stacks. Also, we say, hey, it's the first line because we need to still initialize things, right? So we go through each line. That is happening in either case, either finding out the stacks or going through the procedure. Okay. First, in the stacks stage, we set I to 0, and we check while I times 4 is smaller than line, the length, and we want to keep going. Y times 4. Because we're jumping always by an index of 4, because each crate is essentially 3 wide, and each of them have a gap of 1. So the starting, I always want to be a multiple 4. 0, then this is 4, then this is 8, and so on, right? So that's what I want to do with each of those. If it is smaller than length, it will be back here, and bigger than length, then it will be back here, and like, oh, yep, I can't actually read any more stacks. So this is why we're doing this part, okay? It's not gonna even go into this part if we're on this line, because I is already smaller, I times 4 is already smaller than, or equal than the length. And if we see that it is equal to 0, the length, then I'm going to say we're going to change the state, and we're never going to go into this part anymore. We're also going to say first line is false. Once we are done with this first line. What else are we doing? If it is the first line, we are adding just an empty array into the stacks because we don't know initially how many stacks there are. Obviously, you could count. Okay, we know here now we have 9 stacks. I could have already initiated this with 9 stacks. I didn't want to. I didn't want to count and stuff, just do it programmatically. But these are things that you can do to just shave off time in your actual solve. It's like, instead of programmatically adding this, just count and look. Sometimes that is faster. Then you have if, and then we check the value. If the value is nothing, or numeric, which is either an empty crate, or this is list down here, then we just want to continue, and we don't care about this. Otherwise, we want to insert that value into the stack that it belongs to, which we keep track of with this I as well. So that is filling the stacks, which is amazing. And here it's important we're inserting before, because we're going from the stacks from the top to bottom. So we're always inserting before and pushing everything further up. Now, the else is actually not as complicated. It's actually fairly simple, because in the else we go through and check how, like, we're going through the procedure and working our way through all of the different crates. So first I'm splitting by this text, the amount, and then the leftover text. And then I say from and to. And what I'm doing is I'm essentially just splitting with this text, but I'm also mapping through and making every single bit of text a value, an integer value, and subtracting 1 because I want them to start at 0 and not at 1. And I need to make it a tuple so that they can read it. So I have from and to here. Amount I need to rework because I don't want the beginning text, and I want it to also be an integer. So this is how I get my 3 values that I need. Now, the way that this task works changes between the first half and the second half. In the first half, we go through every single, we go through a for loop in the range of amounts. So this is the amount of times that we go through the for loop. And we say, we take the value of the stacks, okay, and pop it. Pop means it takes the top one off. It returns it into this value. So we already have the take the box, and now it's taken. And then we say here, okay, and append it on the other stack. And it puts it down, okay? And we do that again until the range is done. That's how it does it individually. This here was the time lucky because my research, like I was like, how do I do this in Python that I can take multiple? So what happens, so we have push or append to do individual items, but extend takes a list, and it itself goes through every single items of those lists and appends it at the end, which is exactly what we need. So what are we extending? We are extending the target stack by the from stack. And where do we do this? We take the index for minus amount. If you have a negative, it doesn't start at the beginning, it starts at the end, and it works itself backwards, which amount was perfect for, because minus amount then says, okay, take the last 5, 10, or however many, and keeping after the column, keeping it empty just means until the end. So we add all of these to T. They are still in F. So unlike pop, where it takes it out, we needed to delete those items. And apparently, and I didn't know that, so I learned something new. And that is what these coding challenges are amazing for, because you learn something new every single time, right? Apparently, with delete, we can actually delete these actual instances, these values inside the list. At the very end, after we have done all of the procedure, we just get our text for each stack. We just take the top, and we can pop it. We can take the top off. We can take the top value away. It doesn't matter because it's discarded afterwards anyway. We just add it into S1 and return S1, and we are done. I hope this has been helpful, and that was fun for me. I think this is just, it doesn't like the way I did camel casing. I think it prefers this. Yep, it does. So Python likes its own syntax, and I think for that it needs to be like this. And now it's not annoying us anymore. I hope you enjoyed this, and I hope this was helpful. Again, if you have any suggestions to do things faster and to improve, I would love your input, and I will see you this time for real, December 1st, after I do the first challenge. Auf Wiedersehen!